Hi, in this video I'm going to show you how to do reverse engineering of this object. It's a salt spreader basil. It was scanned and sent to me by a viewer from this channel. He told me that he used Fusion 360 and Autodesk Inventor, but he didn't know how to get started reversing a part with this shape. It's a salt container, thin shell object, probably 2 millimeters in a thickness. There are several ways to reverse this part. One is by using a loft command, and the second would be using the surface modeling. If you use the loft command to model this object, you need to cut cross-section multiple times like this. It will take a longer time. Creating 3D layers can be very difficult. So many curves that you need to create, especially there is a ribs here. It curves in both directions and it's quite thin. If you are using the loft command, it will take a very long time to do it. So in this video, I'm going to use another approach. In most professional CAD software, you can create a surface patch. First, you need to be able to draw this 3D curve. It's going to curve in two directions. And then you make a cross rail to create a patch surface. After you stitch all the patches together, it will turn from surface into solid. Then you can hollow it to the required thickness. The key is that you have to be able to create these 3D lines that define the shape of the object. So this blue 3D curve is going to be created by using two of the 2D sketches. So I'm going to make a simple 2D sketch and another one like this in two planes on the XY and the XZ planes. So I'm going to use a command called intersection curve to intersect the 2D sketches and create 3D lines in the blue color. This one is a 3D curve. This approach is widely used in the product design. You can also use this to reverse most of the car body, car trims. Sometimes it's faster than using the loft command. Sometimes it's slower, and not every CAD software will have this intersection curve function. Okay, this is the 3D connection website. The CAD software that support intersection curve will be Inventor, SolidWorks, Solid Edge, Rhinoceros, Cartier. I'm not sure about the Clio. FreeCAD cannot do the 3D line, so it's not support. Fusion is not directly support intersection curve. You need to intersect two surfaces. And same for the AutoCAD. AutoCAD also cannot do the curve intersection. For the Autodesk Inventor, this function has been around for years, more than 15 years. Okay, this is in the Autodesk Inventor. I have already aligned the point cloud to the origin point. I start by creating the new part. And next I'm going to crop just the extreme bottom edge. What I'm doing here is tracing the point cloud with multiple arcs and lines. Okay, next I'm going to make a second sketch on this plane. The bottom edge of the basil is curved, but the curve is very small, about 1 millimeter. So I think it's not curved by intention. It's curved because it has been used and deformed. So I'm going to use the straight line for this. Next, I'm going to intersect this curve to this curve, make a new 3D sketch, and use this command, intersection curve. Click on OK. Now you can see there's yellow line here. It's a new curve. And I'm going to mirror this line. Apply it, done. Okay, now I have a first sketch, second curve. I need to create a new sketch. Okay, this will be the 2D sketch. Another sketch. on this plane. So this line, this sketch will follow this curve along the side. Another 3D sketch here, and I'm going to create an intersection curve by using these two sketch. This will be the sketch 1 and this will be the sketch 2. Click on OK. Okay, now it's getting close enough because I need to leave some space for the fillet. Let me check the side. Okay, now the line is close enough to the surface. Mirror this 3D line. Let me turn this off. So we have two 3D lines ready to make a patch surface. Offset to about this. Create another sketch. Create another 3D sketch, intersection curve. Select the first sketch, second sketch, click on OK. Because you cannot mirror the patch surface, you need to create each patch individually. And as I said before, you cannot mirror the patch, so you have to make a several click to make a patch. Okay, next I'm going to close the top lids. Next I'm going to close the bottom lid. We have a closed patch surface. Now I can convert this into a solid. Click everything, click on stitch, click on apply. Now I have a solid. Next I'm going to create a ellipse here. It's a 3D curve, very difficult to model with other method. Okay, I'm gonna use the same old sketch to create an ellipse. Going to offset this, and for this I'm going to offset it down for 1 millimeter. 7 mass size 6. Intersection curve. Gonna start with this one and this one. Intersection curve, this one and this one. Okay, this will be the second curve. Intersection curve, this one and the one on the top. Intersection curve, the inner one and the one on the top. So I have 4 3D curve. Next I'm going to create a patch surface by using the 3D lines. There are a lot of patches to make because it has to be watertight to be able to turn into the solid. I don't think there is an alternative way to model this. Okay, now I have a closed patch surface. Next I'm going to stitch it together to create a solid. Okay, now I have a solid. The ribs and the bezel is not connecting into the same pieces. It's a separate body. I need to combine two body together. For that, let me move this face to here. I'm gonna click on solid bodies, click on combined, click on OK. So now these two bodies will be combined into a solid. Next I'm going to make a loft cutting into the solid using 3 sketches. I never thought that the salt spreader will be this complex for modeling. I thought that I was making a helmet. Why do they make it so complex for such a simple device? Okay, now I'm going to select the 3 sketches and use the loft command to cut it into the solid. Now I'm adding the wall on the top of the basil because it's still in the solid, not hollow. It's easier to do it now before making a shell command. Now it's time to execute the shell command. I'm gonna use 2.4mm for the wall thickness, and I'm gonna remove this bomb face. Click on OK. It's gonna take some time to process. It's very complex command. Okay, so we have a shell. Okay, next I'm going to make an opening here. Let me cut this through. Okay, next I'm going to do fillet around the edge here for 10mm. Now I'm making extrusion for the fixing point. I'm going to neglect the stiffener because it will be more difficult to print. And then I make an extrusion for the clips. And then I make a simple extrusion for the edge stiffener. Okay, here's a finished model ready for printing. Okay, this is in the Creative Print version 7. I drop the files here. The step files that you import from the CAD software, it will turn into mesh in the slicer. Some people think that the step files in the slicer is a CAD files, but in fact it's a mesh files. What? See here, the quality of the step file is bad. Yeah, the number of triangular files is really low. So I need to save this file as STL files. Okay, you can see that the mesh quality from the STL file is better, much better than step files. Okay, I'm gonna choose the Hyper PLA for printing this, and the new version of Creative Print, it has automatic orientation. I want to try it. Minimize support volume. Let's try this. Takes quite a long time to calculate. Okay, so this will be the orientation select by the software. Okay, let's trust the software. Okay, so let's check, see if there is any error. Yeah, I doubt that this one will fall. Maybe I have to paint the support. Okay, now it's much better. You can see that the support is about the one in the bombs. Okay. The printing time is what? It's 9 hours? Yeah, I choose less support rather than the printing times. I need to check carefully because it's quite long print. I click on start printing. The new K2 Plus firmware, it changed how it probes the bait much faster. Usually it will probe twice, this time it probed only one time. And it only probes for the area that it's going to print. And with the new firmware, now you can add filament to the CFS during the print without pausing it. Easy, nothing is breaking it. Okay. The easy part is gone. Now it's confused. This looks like a tree support, so I pull it. Okay, here's the result. Each corner is quite pronounced. And you can see that the area where the support is quite rough, but it's small area, and I use automatic orientation in the slicer. I think it's worked very well. So it's automatically determine what is the best orientation when print, and it gives a very small contact face on the support. I accidentally pull out one of the support pin here because I thought that it was the 3 support. It looked quite similar. Very nice and clean print. I think you can sell this. A little bit of sanding. If you use ABS print, you can sand it, and it should be good to go without painting. One thing I noticed with the new firmware update on the Creality K2 Plus, the ringing is gone. See here, usually I will see a ringing from the high-speed printing, but now it's gone. Very smooth. I cannot see even one single ringing. Very small, faint ringing line, but a lot less than the former firmware version. Okay, thanks you guys for watching. I see you in the next video.